Okay, so I want you to study the types of statistics, okay? Types of statistics. If you need a scratch paper, I have a scratch paper here, okay? So types of statistics, you just go to their definition. You don't need to memorize, okay? Just know the concept, okay? So you have a question from the type of statistics. One question from type of statistics. You might be asked that writing an example or just classifying, okay? So make sure you know what is the type of statistics, what are the types of statistics, okay? The next, make sure you know the types of data. So we had qualitative and quantitative data. So make sure you know what are those type of data, okay? Now, the next topic I want you to prepare is data collection method. Collection method. There is like 3 or 4 method of collecting data. Okay, so this is I think from chapter 1. Okay, so make sure you know those name or like the example. Okay, but you don't need to memorize the definition. You'll have the option to pick. The next problem will be from pie chart. Okay, it will be from pie chart. Now from the pie chart, you might be asked to draw pie chart or interpret or gather information from the pie chart. You have the 2 options, okay? So you will be asked to draw pie chart or you gather information from the given pie chart. You will be given a pie chart and you have to answer the question on the basis of that pie chart, okay? So these are the 2 options for you. The next, so you'll be asked to find this interval, okay? So like 1 standard deviation, just like this is 1 standard deviation, right? Number of measurement within 1 standard deviation. This is 2 standard deviation. This is 3 standard deviation. 3 sigma. So you might be asked to like what is the number of measurement that we can find within 1 standard deviation, or what is the number of measurement that you can find within 3 standard deviation, okay? So this one is 1 standard deviation, 1 sigma. 2 standard deviation means you are finding this one, okay? If you are asked to find the number of measurement, or if you are finding the interval or the number of measurement within 3 standard deviation means, so this is within 3 standard deviation. This is 2, this is 1, okay? The next type is stem and leaf. Stem and leaf. This is a graphical method of representing data. So here, very similar to pie chart, you might be asked to draw a stem and leaf, or you might be asked to answer the question based on given stem and leaf, okay? So you have to be ready for both, okay? You must be able to draw this picture or answer the question from the given stem and leaf. So you should know what is stem and leaf, so make sure you go through this topic, okay, from lecture handout. The next one, you will be asked to find mean. This is the easy, right? You will be asked to find median. This is the easiest. You will be asked to find mode. You will be asked to find range. The formula will be given to you. You will be asked to find variance. You will be asked to find standard deviation and interpret. You also need to prepare on interpreting this number. Yes?
How do you get mode again?
Mode is, okay, now you have a set of data, and mode is the measurement that occurs more frequently. Okay, like for example, you have a 9 and 9 occurs a maximum 10 times, then that 9 is mode. Okay, mode is the measurement that occurs most frequently. And you must be able to interpret. So what is median for you? So you must write the meaning, okay? Next one, you'll be asked to find the Z-score. Find Z score. Okay, the formula will be given to you. The next one, you should know about mutually exclusive. What does this mean for you? And if you know the definition, I'm pretty sure you can solve the equation that you have for final. Okay, so you should know what is mutually exclusive mean. Next, for the two different event, you might be asked to find P of A union B or P of A intersection B. Okay, A and B are any events. A and B are events. Okay, A and B are any two events, and you might be asked to find the A union B, probability of A union B, or probability of A intersection B. The next type would be, now you will be given a table, the probability, okay, you will be given a discrete random variable. Now, does anyone recall what do we use to represent a discrete random variable? Or the probability distribution of discrete random variable? What do we use to represent probability distribution for discrete random variable? It's table. Okay, so you will have a table x or P of x. Okay, this is one of the way to represent the probability distribution of discrete random variable. And if you have this, you will be asked to find E of x, which is expected value. So you must know how to find expected value. You must know how to find this standard deviation. Do you recall this problem? You have the table, the values of x will be given, P of x is given, and you have to find E of x, standard deviation. The formula will be given to you, but you should know how to find. The next one, you will be asked to find the probability, okay, for continuous random variable distribution. Okay, so if you have continuous random variable, how do we represent the probability distribution for continuous random variable? We use a graph. Okay, so you have seen the graph of a bell shaped, you might have a graph of a rectangle shape, right? If you have a bell shaped, how do we find the probability? This is what we did in our last class, right? We use the Z table or Z score. Okay, this is the uniform, so it will be given, the formula will be given to you. So this is one type of question you will have. Okay, the next I want you to read what is central limit theorem. Okay, central limit theorem. Now central limit theorem has a formula in it. Okay, you will have that formula, but you should know where to use that. Okay, central limit theorem has a formula. We have a two formula. Who can tell me what is the formula in the central limit theorem? What it gives us? This is, I think we haven't done here, but so there is a formula, mu. The mu of sampling distribution of mean is equals to mu, and the standard deviation, okay, of sampling distribution of mean is standard deviation of a population divided by square root of n. Okay, so you should know that you will be using central limit theorem, and there is a condition when to use this central limit theorem. Okay, next one, you will be asked to find confidence interval. That's what we practiced. Confidence interval and interpret. Okay, you should write down the meaning of that interval for you. So make sure you practice a question where you are asked to find confidence interval. And if when you are finding the confidence interval, you make sure you know the parameter, sometimes there might be a parameter mu or parameter p. Okay, the formulas are different for different parameter. So this is one type. The next type is you will be asked to find sample size. Okay, you will be asked to find sample size, and there is just two formula to find the sample size. Okay, make sure you know how to find the sample size. The next one, test of hypothesis. Okay, and I think you have at least minimum two question from test of hypothesis. Okay, now in this type of question, so you will be asked to write down the null hypothesis. So you should know how to write the null hypothesis, alternative hypothesis. You should know how to find test statistic. Okay, you should know how to find test statistic. You should know how to find the rejection region. Okay, rejection region. You should be able to make a decision with the help of test statistics, and you might be asked to find the p-value as well. Okay, so whenever you are practicing this type, okay, you just, I think once you know the concept, or once you just make a review of what we did in the class, or if you practice your fourth exam, you should be able to use very similar. Okay, but do not expect exactly same question on your final. The type is very similar. Okay, so make sure you practice this one. And the last type is the least square line. This is the one that we did in chapter 11. Okay, you will be asked to find least square line. You will be asked to calculate r. You will be asked to calculate r squared. Okay, so r is the regression coefficient. Okay, and r squared is the determination coefficient. So make sure you do a review of chapter 11. Okay, so this is from chapter 11. And once you prepare this topic, you are good for your final exam. Okay, now we haven't completed our review, but do you want to do a review of any topic from here? If not, I will continue from where we left yesterday. And everything will be provided. You will have a z table, you will have a binomial table, you will have a t table, formula sheet, everything will be there. Okay, no need to print anything. But make sure you practice this topic. Okay. Now, so if you don't have any question, let's go back. Okay, so here. Okay, we were at number 16. Now, did anyone complete number B for number 16? So this is from our exam 3. Okay. Okay, now here, so we have a normally distributed distribution. The mean is given. Okay, so let me draw this one. So normally distribution means we start by drawing a bell-shaped curve. Okay, the mean of this distribution is 1.161. So this is 1.161. The standard deviation is 0.538. Standard deviation is 0.538. This is given to us, and the question is 95% of all earthquakes will be below what magnitude on the Richter scale. Okay, now we need to find the magnitude. Okay, and below that magnitude, the number of earthquake has to be 95%. So here, so these are horizontal axis represent the magnitude. Okay, let me use x. So we are finding x. We don't know what is that, 8. Okay, but what do we know is that 95% of the earthquakes below this x magnitude falls below this magnitude x. Okay, it means the area we are interested in is this area. So this area is given to us as 0.95, and our target is finding x. Okay, now this is at the center. Now can you tell me what will be the area of this region? How do we find the area of this green region? So from left, okay, from here to up to x, it is 95, 0.95. Okay. Now from here to this center, what is the area? Is half, right? 0.5, and the remaining will be this one, right? So 0.95. So the area of this region is 0.95 minus 0.5, which is 0.45. Okay, we know the area of this region. Okay. Now we know the area of this region. Now once we have the area, what can we find? So once we have the area of this region, what can we find? The corresponding z value from z table. Now use the z table and you look for a number close to 0.45. Now can you give me the corresponding z value for this 0.45? Use the z table and look for the number very close to 0.45, and the corresponding z value will be z value for this point, but that is not x, okay? 1.64. Okay, so the z value for this point is 1.64. Okay, now this is z value, but this is x value. These two are not same, but we know how to convert x into z. How do we convert x into z? We have a formula. G is x minus mu divided by sigma. So let's convert this x into g, which is x minus mu divided by sigma. Okay, our x, we don't know what is that. Mu is 1.161 divided by sigma is 0.538. Okay, this is all. Now this is g, this is also g, this is also g of a same point. If that is the case, it has to be equals to each other. So this is equals to 1.64. Now you solve this equation and find the value of x. Okay. Do you have any question here? X is not 1.64. Okay. From the z table, we get the z value. Okay, any question number 16? Okay, for number 17, okay, I think it's okay if you don't practice A, but you should practice B, okay? Okay, who can tell me number A? What are your answer for number A? Can you tell me what is this? So this is 3, right? So this is 3, 4, 4.5, is it 5? Now what is this? So this is 0.08, and this one 0.16, this one 0.18, and this is 0.09. Okay, now don't worry about this one, but you should be able to find solve this type of example. Okay, like here what we are asked to find the probability that x bar is 4.5 or larger. Sergio, yes.
Do you know how to solve part A? How do you solve it to get those?
No. So I mean, like, you'll be given the table. Okay. So on your final, you are not asked to fill this table. You will be given a table. Okay. You will have this probability distribution table, and from this table, you should be able to answer this question.
But just to know how do you get it?
Oh, now okay. Now if you now here. Now, so you find the mean. So here you find the mean of these two, mean of here, mean of this, mean of this. Okay, like for example, let's say 3.5. Now, how many? Okay, so the mean of these 3 and 3 is 3, right? Mean of 3 and 4 is 3.5. The mean of this is 4. 3, 6, that is 4.5. The mean of 4, 3 is 3.5. Okay. Now similarly you find the mean of each sample. Now you look for the mean 3.5. Okay. So we have how many 3.5 we have? We have 3.5 here. We have 3.5 here. We have two 3.5. Now the sum of the respective probability is the total probability. Okay. The probability of this 3.5 is 0.04. The probability of this mean is 0.04. Okay. We don't have any more 3.5 mean. So the sum 0.4 plus 0.4 is 0.08.
And so why do you need that left table for?
You mean this table?
Yeah.
Oh, okay, this table, if you, okay, now here, I don't know, now for this question you may not use this one, but if you are asked to find mu, for example, if you are asked to find mu or sigma, you're going to use this table. Okay, this is for the population. Your x represent the x, this measurement is of the population. This is your sample. Okay, now yes, you are right. In this example, yes, there is no question that you have to use this table because I didn't ask you to find mu and sigma. Okay, but on your final, you will be given this table. But from once you have this table, you should be able to find this probability. Now here, our probability x bar is larger or 4.5 means greater than or equals to 4.5. Now, how many mean do we have equals to 4.5 and greater? So we have 4.5, 5, 5.5, 6. So this is probability of 4.5, that is 0.24 plus probability of 5, 0.21 plus probability of 5.5, 0.18 plus probability of 6, 0.09. And that is the probability here. Okay. So this is the, we can also call discrete probability distribution here. Any question? Okay, now here, I think I should have given this sample size larger. Okay, so let me take this sample size like 36. Okay, now we have a sample size 36 from a population. The mean of a population is 6. The standard deviation of a population is 5, and you are asked to find mu of x bar. This is not x, so this is mu of x bar. This is mu of x bar means sampling, the mean of a sampling distribution of x bar. And what do we use here? So this is let me write down what does this mean for you. So this is mean of sampling distribution of mean. Okay, and since now here at this point we use the central limit theorem. Okay, since the size is greater than 30, we use the central limit theorem, and according to central limit theorem, the mean of a sampling distribution is equals to mu of a population, which is 6. Now here, this is the standard deviation of a sampling distribution, and the standard deviation of a sampling distribution of mean is equals to standard deviation of a population divided by square root of n. So that is 5 divided by square root of 36, that is 5 divided by 6. Okay. Now here, so at this case, make sure you are using these formulas. The formula will be given to you. Okay, but you should know where to use this one. Okay, any question for number 18? Okay, so if you are okay, now for on Mondays, it's not mandatory to come on Monday, but if you come, I will be here. Okay, so if you have any question, I'll be in my office room, or if we can find any room, then we can sit together and just discuss. Okay, but it's gonna be exactly the same time, so I'll be here at 12. Okay, now here, okay, I'm looking for the parameter here. I don't want to read this one. Okay, mean. So we have mu equals to 6. Okay, the standard deviation is 10. 331 is the sample size. What is the probability? Now, what is the probability the average blood is greater than 7.5? Okay, we are asked to find probability that the average blood, okay, so X bar is greater than 7.5. Okay, now what kind of distribution is this? Without this, okay, now does it mention the type of distribution here? Does it say normal? Okay, I think I need to read one more now. I think I need to read here all. Okay, chemical used in product that coat cookware to prevent food from sticking, and agency is investigating the potential risk of PFOA, cancer causing agent. It is known that the blood concentration in the general population has a mean. This standard deviation. Oh, okay. Here we use the central limit theorem. Okay. Now we are asked to find the probability that average blood concentration. Okay. Since the sample size is greater than 30, our sampling distribution of mean. What will be the shape of sampling distribution of a mean if we have a large sample size? Normal. So we draw a bell shape. So it's relatively normal. Okay. Now our X bar is somewhere here, 7. So this is your X bar. Okay, not X. 7.5, and we are looking at the probability on the right of 7.5. Okay. So this is the region. So we have this center somewhere here. Okay, we don't know what is the mean here. Mu of X bar, we don't know what is that, and we need to find it.
On the top it does say mean equals to 6.
That is the mean of a population, but we are interested in the probability of average. It means the probability of sampling distribution of X bar. It means we need to know the mu of X bar. Okay, and the mu of X bar will be same as mu from central limit theorem, so this will be 6. But the standard deviation of a sampling distribution would be this 10 divided by sample size, square root of sample size, 331. Okay. Now once you have this, how do you find? You have a now. Yeah, I think this is what we did yesterday. How do we find the area of this region? This is 6. This is 7.5. Are you ready to use your G table here? Now before using G table, this is a bell shape, so we can use the G table. But before using G table, what do we have to do to this number? We have to convert into G. So convert this 6 into G. Convert this 7.5 into G. Okay. Now you have a G value. Use the G table. You get the area of this region and subtract from 0.5. You get this area. Okay. Okay. Let's do this much for today. Okay. You can also go back and watch the review video of exam 3, exam 2. Okay. And as I said, on Monday, if you need help, yes, you are welcome. And one more request, make sure I have very few students participating from this class in the course evaluation. The due is December 8. It does not take time, like I think 2 to 3 minutes. So once you have time, please, okay, try to complete that course evaluation. And I would be happy to read your comments. So if you have any comments, please do comment for me. Did you complete this one? Okay. All right.